So now we're going to take a look at division of exponents, and here we have the rule, and it says if I have the same bases raised to different powers, so a to the m divided by a to the n, that is the same as subtracting the powers. So an example of that would be x to the fourth divided by x to the third. Well, that's the same as saying x to the 4 minus 3 or x to the first. The reason why this works, well, let's take a look. If I have x to the fourth divided by x to the third, what does it mean to be x to the fourth? Well, that's x times x times x times x. And x to the third is x times x times x. Well, if I cancel out on the top and the bottom factors that are the same, then I'm left with x to the first power. So that is why that works. Another rule that we have is that if we say we have a raised to the negative n power, that is the same as saying 1 over a to the n. So an example of this would be a to the negative 2. That's equal to 1 over a squared. Also, if I have 1 over a to the negative n, that's the same as saying a to the nth power. So what happens is we get rid of the negative exponent. So an example would be 1 over a to the negative 2 is equal to a squared. Okay, now let's see what happens if we take a divided by b and all of that in parentheses is raised to the nth power. Well, that is the same as just taking each part and raising it to the power. So that's the same as saying a to the nth and b to the nth. So an example would be as if I had a divided by b and all of that got squared, that would mean a got squared and b got squared. The reason why this works, we can see, is that a divided by b squared, well, what does that mean to be a divided by b squared? Well, it means ab times ab, and that gives me a squared divided by b squared, because a times a gives me a squared, b times b gives me b squared. So that's why that works. Anything raised to the first power is just itself, because you're just having it. This is how many times you multiply something by itself. Well, that's just multiplying it by itself. So 2 to the first would be 2. Now let's take a look at something else, which says a to the 0 equals 1. Anything raised to the 0 power is equal to 1. So let's take a look at some examples of that. If I have x to the 0, that's equal to 1. And 20,005 to the 0 power is equal to 1. So anything raised to the 0 power is equal to 1. Let's take a look at why that's true. Here's a little proof. Well, if I go a to the n divided by a to the n, that's the same thing as using our rule that we just had of a to the n minus n. When we divide and the bases are the same, we can just subtract the exponents. Well, n minus n gives me 0, so that left me with a to the 0. But if we look, we also see that a to the n divided by a to the n is also equal to 1, because anything divided by itself is equal to 1. So this shows me, since a to the n divided by a to the n is equal to a to the 0, and a to the n divided by a to the n is equal to 1, a to the 0 is equal to 1. So let's take a look at how you might use this with some problems. So it might say simplify expressions. You might have y to the 5th divided by y cubed. The whole thing gets squared. So I'll go ahead and do what's inside parentheses first. I'm still going to use my PEMDAS rules. So that's the same as saying y to the 5 minus 3. All of that's going to get squared. So that's the same as saying y squared squared, okay, because we subtract when we're doing that division. That's our little rule. And when I have a power raised to the power, we multiply those. So that gave me y to the 2 times 2, which is y to the 4th. Here's another example. If I have x to the negative 8 times x squared, well, x to the negative 8 is the same thing as saying 1 over x to the 8th. And then times x squared, well, that's the same thing as saying x squared over x to the 8th. I'm going to use my little rule, which says x to the 2 minus 8, and that gives me x to the negative 6. And we don't want to keep things in negative exponents, so I'm going to flip that down. That's 1 over x to the 6th. So notice, I don't change this and make this negative. All I do when I have a negative exponent is I'm going to put it in the denominator and get rid of that negative. So here is another example. If I have a cubed squared times a to the negative 4th and a to the negative 4th cubed. What I'm going to do first is go ahead and take my power to the power. So that's a 3 times 2 times a to the negative 4th, a to the negative 4 times 3. Well, this became a to the 6 times a to the negative 4 over a to the negative 12. And what I did was I then flipped my negative. So this negative went down into my denominator, and this negative exponent made that flip up here, and I was able to get rid of the negative exponents. Well, now I'm multiplying across. The bases are the same, so I can add the exponents. So I went ahead and did that, and I got a to the 18th over a to the 4th. Well, now I can use my rule. When the bases are the same, I'm going to subtract my exponents. So I subtract my exponents, and I get a to the 14th.